Hey there, if possible, pause this video, attempt this question, comment in the description box if you found this video useful, and like the video. It helps out the algorithm. So what fuel is used? Well, the fuel is uranium. Usually it's uranium-235, or it could be sometimes plutonium-239. Now, it's not a renewable energy source. One day we are going to run out of it, but approximately for the next 5,000 to 10,000 years, we're safe to go. Now, for the second bit, we got to know what is a control rod. So a control rod is inserted. And usually it's made out of boron. It could also be cadmium. It could also be silver. In some cases, indium. Now, what a control rod does is it absorbs some of the neutrons. So you need neutrons to start a fission reaction. So I could show you a picture, but you got a uranium-235 nuclei. So you look at the nucleus. It's an atom, yes, but it's all about the nucleus. And you fire a neutron at it, okay? And if you know anything about a chain reaction, you know the uranium-235 splits up to two daughter nuclei, so two different things. And it gives off two or more neutrons. So with one neutron, you've got now two or more neutrons. So it's a chain reaction. You're gonna and those neutrons go and collide with other uranium or plutonium or whatnot, and you got a chain reaction going on. Now, if you don't absorb these neutrons, if too many reactions are going on at the same time, too much energy is going to be released at the same time. So what does that go? Kaboom, a big explosion, and you do not want a nuclear disaster. So these control rods are inserted inside to absorb some of the neutrons so it doesn't get out of control. So the answer for this is boron. Now, what is a moderator? A moderator slows down the neutrons. It could be graphite. It also could be water. And the way it slows it down is it collides with the actual high-speed neutron and reduces the amount of energy it has. So energy is interlinked with kinetic energy. So if you reduce the energy, reduce the speed, the kinetic energy. It slows down the neutrons. Why do you want to slow down the neutrons? It gives it a chance so that the neutron could actually successfully collide with the neutron. If it's traveling too fast, it won't happen and you won't get a chain reaction. Now, it goes with our second question. Why does a nuclear fusion reaction don't need to slow down the neutrons? So let's look at this image. Okay, so this is a fission reaction where the nuclei gets split up. A fusion reaction is the joining of two nuclei together, and that creates energy itself. The way both of these work, you don't need to know about this, but some mass is being lost each time you're doing this. Okay, so with this and this, there's some loss of mass. Now, mass cannot just be lost; it's converted into energy. Hence, why both reactions produce energy, but they produce energy by different ways. In the fusion reaction, you do not need to absorb a neutron. Hence, it does not need to be slowed down. If anything, it needs to actually be sped up, the whole process of combining two nuclei. The reason being, the nuclei are positively charged. This comes up to another question, but they're positively charged, so they're trying to repel each other, the nuclei. So you need a lot of temperature, a lot of because temperature is linked with kinetic energy. You need a high pressure to push them towards each other. You need all of this to do a successful fusion reaction. Both a nuclear fission and a nuclear fusion reaction release thermal energy, so heat. Describe how thermal energy release could be converted into electrical energy. Well, that's to do with a generator. So these are some pictures of generators. Basically, what the does is the heat is used to evaporate water. When the water is evaporated, it turns into steam, and the steam turns this turbine. Now, what's in the turbine is magnets that are moving within a coil of wire. And if you do electricity later on with me, that can create a voltage. So that is the whole way of this working, is by moving a bunch of magnets, which induces a voltage, and that's it. So the answer was thermal energy used to boil water, turns a turbine, which generates electricity. And that's it. Scientists and engineers are still trying to build a practical and economic nuclear fusion reactor. What they mean by economic is Actually, they've done it recently. They already created it as an economic one, but it's not been, how do I say, it's been for like 105 seconds. They basically, the energy they put in, they get more energy out than they actually put in. This was the tricky part, and they've done it for 105 seconds. But not, I believe China and a few other countries. But this is they're not updating the GCSE syllabus, so this is not the new thing. But that's what they mean by economic fusion. If it ever comes up in a question, that's what they mean by getting more energy out than you put in, but making it stable for a long period of time is the tricky part. They're still trying to build a practical one. That's maybe the issue, making it stable. They have not been able to sustain the extreme conditions needed for, so that's what it means for a longer period of time. Explain what these conditions are and why they are needed. So basically, let's start with why they are needed. With a fusion reaction, I told you before, but the nuclei have to be fused together, and the nuclei are positively charged. So there's an electrostatic repulsion force, and you need high temperature. You need a high speed to overcome that repulsion force, and you can achieve this with a high temperature, with a high pressure, and the high kinetic energy is can overcome the repulsion. They also accepted the idea of high density, but I would just say high pressure, which increases the probability of a successful fusion reaction. If you found this video interesting, please subscribe to my channel. I post daily GCSE math and science videos. Take care, have a nice day, and bye-bye.